What's up, everyone, and welcome to the live stream for the Algebra 2 January 2024 Regents. I'm going to go through the June 1st, 2016, the first ever Algebra 2 Common Core Regents. So that's what I'll be doing. So to everybody in the chat, hello. Sorry for the delay, but I'm a family man. I have, wife, 2 kids, and I got a little hectic, but I'm here now, and I plan on going through this whole Regents. So thank you to everybody who stopped by or has stopped by. I'm going to get rolling here. So hello to everybody in the chat. Yeah, sorry for the delay. I know. I appreciate you being patient. I know this test is later in the day. So yeah, that's why I scheduled this one for the night. So the afternoon people, hope this isn't too much of an issue. All right. So here we are, aiming for 89%. That's very precise. I love when people have such precise scores that they're aiming for. All right, so I'll just kind of get rolling here. But once again, I'm doing the June 2016 test. All right, I go far back because I know teachers are more likely to do the most current ones in class. So hopefully you haven't seen this one yet. But if you have, it can't hurt to hear another solution. All right. 89 is good. My goal is really 65. All right. Well, do your best. I hope people will be okay. Chemistry honors. Wow. Yeah, if I had to take a chemistry final right now, I don't think it would end well. I like chemistry, though. I mean, I think it's a great subject. That's like one of those subjects I would be happy to teach if I could go back to school. And physics, too, I would love to teach. I taught physics for 2 years. I mentioned that the other day. Oh, in the chat, let me know. I'll ask this periodically, but who would be happy if I did like a physics Regents review in June? Are people interested in a physics Regents review? I'm rusty. I haven't taught physics in like 5 years, but I'd be willing to review it for all of you. It'd be interesting. I'm not going to be as smooth as I am with math. All right, so let's get rolling. Now, when b is greater than 0 and d is a positive integer. All right, so basically simplify this. That's what they're saying. And they're saying b is greater than 0 so that we don't have to worry about taking, square roots or even roots of negatives. So really, it's knowing this rule. So know all your rules. So this is equal to this. Okay? Or you could even say like the c root of a and like all of this to the b power. Like either one is fine. So that's, where my head goes for this question. So the idea, though, is that it's the power over the root. Okay, so just tell yourself power over root. And the root goes in front of the radical. The power attaches here. Okay, but the power could also attach like outside like this. So when I see this thing, I'm like, okay, the power is 2 and the root is d. So we would have the d root of 3b squared. I could write it like this, but then I look and I'm like, oh no, my answer's not there. Or I could write it like this, the d root, fix that. So the d root of 3b, and then put the power outside of this parenthesis. Okay, and it's choice 4. The problem with this one is that it's 1 over. So that would be if we had like this answer here, it would be the d root of 3b, but like all to the negative second. All right, so that's why this one's no good. Let me move that down a little bit. Okay, so that's why choice 1 is like no good. This one is no good because the power is not d, that's the root. So this one's out. And same thing here, the power is not d, that's the root. So definitely 4. Okay, a physics review. So at Ola, I'm glad people approve. I'm really committing to doing a lot, though, if I do a physics review. I would really have to like brush up. But I noticed that I don't think there's like anybody who does physics Regents videos out there. There's like a major opening. But I was a math major in college. I didn't take any physics classes, really. It would have to become a side project for me to learn physics, but I wonder how many people take physics. But I imagine it's growing, the physics programs across the country, so it can't hurt. It might be an interesting undertaking. All right, so Julie averaged 85 on the first 3 tests of the semester. And if she scores a 93 on each of the remaining tests, her average will be 90. Which equation could be... Wow, this is mean. Man, they were not playing around when they brought this Regents out. Okay. So this one I really have to think about. So an 85 on the first 3 tests just means like... Just know, like, when you're finding, like, your average, it's, like, equal to, like, your total points. Okay, so, like, your total points. Or I should say, like... Yeah, this is really just, like, not erasing well. I'm sorry about this pen stuff. It's going to annoy me. This is, like, your test points. Let me write it like this. Like, your total test points. And this is, like, divided by, like, the total test points. All right, what I mean by that, like, let's say, I don't know, somebody got like a 83, 75, and a 90. Yeah, like your total test points would be this. So 83 plus 75 plus 90. And actually, you know what? I could just say like divided by the number of tests. Let me just fix that. Sorry, I'm like warming up here. Divided by the number of tests. Yeah, if you do it out of 300, like, it's still going to work, but it's going to write it as a decimal. Okay, so dividing by the number of tests is probably the nicer way. And t is how many tests. Like I said, dividing by the total number of points would still work, but this is better. So you do this, and, you know, this is going to tell you, like, what your test average is. Okay, so if I had, like, 83 plus 75 plus 90, and then divided by 3, so your test average is, like, almost an 83. Okay, it's like roughly 83. All right, so like that's the concept you need. All right, this is the concept. Because if you don't get the concept, these questions are like not polite. All right, so know your percents. All right, so Julie averaged 83 on the first 3 tests. That means like she got 85 times 3 points. Okay, this is her like total points on the first. Yeah, this is... I'm going to have to do something about this program. It's going to drive me insane. So total points on first 3 tests. Maybe I'll just like reset the program, because this is going to get old for me real quick. This happened like all day yesterday. All right, so 85 times 3. And now plus, if she scores 93 on each of the remaining tests. Well, think about this. If there's t tests left in the semester, okay, which equation can be used to determine how many tests t are left in the semester? So if t is the number of tests left, just think about this. The total, you see how like the number of tests, so the number of tests would be t plus 3. Because you see, she got 85 on the first 3 tests. Like that was her average on the first 3 tests. And that's 3 tests she took, but there's t tests left in the semester. So we're going to be dividing all of this by t plus 3. Okay, but they're saying here, if she scores 93 on each of the remaining tests, so that would be 93 times t. Okay, because if there's t tests left, times 93 would tell us the total points on the remaining test. Okay, so total points on the like remaining tests. Okay, I'm just gonna abbreviate because I'm getting tired of writing. So now 85 times 3, I'm just gonna say is 255 because every answer has 255, plus 93t divided by t plus 3. Okay, oh, and they're saying if she does this, her average will be 90. So the average here is gonna be equal to 90. All right, and then you can see that matches up with what we have here. Okay, so that's why. Now, the reason why we're not doing these choices is because basically they're saying the total number of tests is like 3 times the number of tests remaining. But remember, if you're trying to find her total amount of tests, she took 3 tests already. You would add t and 3, not multiply. Okay, so that's why that's no good. All right, and then this one's no good because they're saying 90 times this, but they're saying she scores a 93 on each of the remaining tests. So the 93 attaches to this part here, not the other way around. All right, I'm glad that one's over. That one was not pleasant. It gets easier though. Some people, oh, they never taught you calculator tricks in class. I'm going to teach you plenty of calculator tricks. My teacher told me you could pass using the calculator to some extent at Magnus. The Algebra 2 Regents is like a little bit harder to pass with just the calculator. But if I had to, I guess you could pick out, like, if I had to use the calculator for this. So you ready for some tricks? All right, here's a trick. Let me see if it works. So for 3, I would go mode, and this is imaginary. So you see how we have real and then a plus bi? So I could switch this to a plus bi. And then I could just pick out a random value for y. Like, let's say, let me clear this. Oh, wait, is this not behaving? Hang on. So let's say here I just go 2 minus, and I'll make y equal to 3. Okay, so 3, and then I is second decimal, and then I square it. And now watch this. See, negative 5 minus 12i. And then what you could do is, like, you could just plug in y equals 3 to all of the answers. All right, so you see this? I said, like, so this is like, I don't want to do algebra. I'm like anti-algebra. I'm going to say, all right, y equals 3. And then I plug in, like, let's say choice 1. I'm like, okay, 3 squared is 9 minus 4 times 3 times I, and then plus 4. But like 9 plus 4 is 13 minus 12i. Doesn't match this. See, it should be negative 5. So I know that's not it. And then I can say, all right, choice 2. And I go minus, put the minus first, then I put 3 squared. And then minus 4 times 3 is 12 times I, and then plus 4. And I think this is it. This is going to be minus 9 minus 12i plus 4, and it gives you minus 5 minus 12i. So, like, yay, I don't know a lot of algebra, but that's my answer. All right, so that's, yeah, your teacher said, oh, you could pass. But the thing is, you got to know how to use the calculator, like, you know, really well. Okay, that's like, yeah. Oh, as of right now, we are using a new calculator. Oh, TI Inspire. Yeah, I'm sorry. The 84 plus CE is like what I know. One day when my school switches, I'll have to learn it. But yeah, so otherwise, it is the Algebra Regents. So I'll show some algebra too. Okay. So 2 times 2 is 4. Then you got 2 times minus yi is minus 2y. And then the I just tags along. And then you have 2 times minus yi is another minus 2yi. That's fun to say. All right. And then minus times minus is plus. Y times y is y squared. And I times I is I squared. So we're here. I squared, this is what you need to know from imaginary numbers, is equal to negative 1. You also need to know that the square root of negative 1 is equal to I. Okay, these two kind of support each other. And now it's just a matter of combining like terms. 4 minus 2, see, these are like terms here, so that's going to make minus 4yi. And this will make plus y squared times negative 1. And now y squared times negative 1, I'll write that first, is minus y squared. And then I'll write minus 4yi. And then I'll write positive 4. Okay, you could kind of reverse the order here, just to see that it matches choice 2. Is there an AP Calculus? Is there a class called AP Calculus CD? At no arrows, no. I think if there were to be Calculus CD, it would be Calculus 3, multivariable calculus. But schools do offer multivariable calculus. Some of them do. It's usually like schools with like a heavy gifted and talented program. Because in order to take a class like that, you'd have to take Calculus BC like your junior or sophomore or sometimes freshman year. Yeah. Do you have an older one available that you are more familiar with? Before. Wait. Do you have an old? Wait, could you explain at Vanessa Kitty, like kind of a little bit more what you mean? Do you have an older one available that you are more familiar with? Yeah. Oh, the Geometry Regents answers are going to take a while to come out. I can't make a video on it until they release it. They have not released it to anybody, the test. All right, even teachers. Like, you know, we of course, like, we get to like see it on paper, but I cannot put it on YouTube until New York State releases it on their website. It's like security locked and all that. Like, that would be in, yeah, so we got to wait. Like, sometimes it takes like a few weeks, sometimes even a month. But you'll get your grades back before that for sure. But you'll find out soon enough. So which graph has the following characteristics? 3 real zeros. So these are the same thing as x-intercepts. So let's see. This one has 1, 2, 3, 1, 2, 3. They all have 3. All right, so this doesn't really help at all. The end behavior is everything. As x goes to negative infinity. So just know, like, x goes to minus infinity means go left. Okay, like, just keep going left. X goes to positive infinity means go right. And just keep going right. F of x goes to minus infinity means the graph drops. Okay, so maybe I'll erase this. I'll do this a different way. I'll explain it a different way. I'll combine everything. So when they say this, like, as x goes to as x goes to minus infinity, f of x goes to negative infinity. What I think of is I say, as we move, how about that? That's a better word. As we move left, the graph f of x goes to negative infinity means the y values drop. So as we move left, the graph drops. Or you could say, or goes down. Okay, like, that's the plain English way of interpreting this. So as I go left, the graph has to go down. And see how 1, as we go left, the graph is going up. So this one's out. This one's also no good. Choice 2 is no good, because here, as we go to the left, the graph is going up. These two are fine. However, the second condition here is this one. All right, and I'll interpret this in a new color. So this one, what I'm thinking about is as x goes to infinity, so as we move right now, the function is approaching infinity, means the graph rises or goes up. Okay, so now we look here. This one is going to have to be choice 3. See, as we move to the right, the graph is going up. But this one is as we go to the right, the graph drops. So choice 4 would be as x goes to infinity, f of x also goes to minus infinity. All right, in both directions here. So that's why it's 3. How much time is allowed for this Regents exam? Oh, you live in Connecticut. 3 hours. So you get a lot of time for it. At Yazan, howdy. Nice to have you on. And I like the greeting. I know I immediately think of, like, howdy, like I'm in Texas or something. I have family in Texas. So, yeah, just brought me back to my family reunion. So thank you. All right, so this one. Ready? This one, there's a shortcut. There's an easy way. So the shortcut for the multiple choice is just plug in. And the reason why I'm okay with telling students to do this is because you're going to have to plug in at the end anyway. When you solve a radical equation, you have to plug in to check your answer. So here I would plug in, let's say, x equals 7. So x equals 7, if I plug in, gives me square root of 56 minus 7 equals 7. Because notice x shows up here and here. So I'm plugging in here and here. And now I just simplify. The square root of 49 is equal to 7. That's a true statement. So 7 is an answer. Okay, 7 is part of our solution set. So that means the empty set is no good. And that also means that this is no good because 7 is not there. So now we have a 50-50 shot of getting this right. But now to be precise, I'm going to plug in x equals -8. But I already know this is no good because you can't have a square root send out a negative. Okay, square roots only send out what we call the principal root. Okay, it has to be positive. So 56 minus x is -8 equals -8. This is already, I could see, not true. That's going to give you square root of 64 because minus minus changes to plus. But the square root of 64 is +8, not -8. So see you later. Choice 3 is our answer. Okay. Oh, you lived many years in Texas, retired. Very nice. Very nice. That's, yeah, I have family in Fort Worth, like kind of like that area, Colleyville. It's really nice though. Texas kind of ruined me in a way though, because when I went there to eat barbecue, the first time I had barbecue there, it was brisket. And the brisket was so delicious that, like, I wouldn't say like it ruined me, but when I got back to New York, I remember going to Dinosaur Barbecue in Brooklyn and just thinking like, wow, this is not even close to Texas's barbecue. Like, it just like, and before I went to Texas, Dinosaur Barbecue was amazing. I'm not saying it's bad, but compared to Texas barbecue, it's like, it's not even a comparison. So yeah, go barbecue. All right, let's see. Would you recommend taking AP Calc next year? You're an AP Pre-Calc, just a sophomore. Yeah, no, for sure. So at not Darian, like, I would say go for it. You know, take the class. It's a good challenge. I would say it's probably good to do Pre-Calc. I'm sorry, to do calculus after Pre-Calc. I'm just gonna take a little water break because you just did Pre-Calculus, and I just dropped my cap to my water, whatever. I'll just make sure I'll try not to spill it. But if you're just taking Pre-Calculus, you should take calculus while Pre-Calc is fresh. Some people do Pre-Calc and then they do AP Stats and then they do AP Calc. But the problem with that is, like, AP Stats is like a lot of reading and like analysis. It's not so algebra heavy from what I've been told. Because I never taught AP Stats, but I know like kind of what it entails. So it's better, I would say, to do Pre-Calc, then do Calc, and then if you want to take AP Stats your senior year, you can. Or if your school offers like kind of like a gifted and talented like multivariable, then you could do that senior year. All right, but it's up to you. Oh, that's awesome at Vanessa Kitty. I would have to like probably move somewhere where I could like have enough space to even have a smoker. That's like definitely like a fun style of cooking. Yeah. MIT. Oh yeah, I'm a teacher. I'm a high school math teacher. I teach 4 periods of AP Calculus BC, 2 double periods, and then I teach a geometry class. But I know algebra too, so don't worry. You're all, yeah, I'll be fine explaining this. Okay, so back to this. Here, I would just say, like, look, if you don't feel like thinking about this, like you're like, hey, I just want to get this right on the Regents, then just type it in, x to the 4. So calculator tricks, y equals, and then I'll show you how to do the algebra. So this minus 9x squared and plus 36x. Now, since the roots are like reasonably close, I'm going to presume 6. Notice we have 1, 2, 3, 4 roots. So if you have okay eyesight, you know, you could just look at this. And let's see. So here it's looking like -3. The graph hits the x-axis at 0, 3, and 4. Okay, so it's, if I write it in this form, it's 0, there's a positive and -3, and 4. So it's this one. All right, so yeah, the calculator is like really like overpowering, you know, if you know how to use it. If you don't know how to use it, then just, I don't know, good luck. If you don't want to do this by calculator though, then you factor out x to the 3rd and you're left with x minus 4. And then you take out a minus 9x from these and you're left with x minus 4. So now you factor out x minus 4, and you've got x to the third minus 9x. And now, again, you factor. This one's like a crazy factoring. All right, of course, like this whole thing is like equal to 0 the whole time. So equals 0, equals 0, equals 0. And then you got x minus 4 times x plus 3 times x minus 3. This is a difference of 2 squares. Cool. And now this gives you 4 answers. 4, that gives you 0. And these give you plus or minus 3. Okay, so you got to use factoring by grouping and then like factor a million more times. But 6 is choice 1. All right, simulations. These questions are kind of painful, but they kind of all have the same flavor. It's usually like, let me see, blah, blah, blah. Yeah, I mean, I always just think plus or minus 2 standard deviations. Let's see, Anne has a coin. She does not know if it's a fair coin. She flipped the coin 100 times. Ooh, 73 heads and 27 tails. Now, I know like the theoretical probability should be like 50-50. This is pretty far away from 50-50. So you can common sense these questions a little bit. Like I'm just looking at this and being like, that coin doesn't seem fair. You know, like if it was like 51 heads and like tails was like 49 times, I'm like, all right, that's pretty close to 50-50. Even if it was like, I don't know, like 58 and 42. I'm like, all right, like that's not ideal, but it's still pretty close. This is like kind of off. All right, this is not looking good. So like if I had to take an educated guess, I would say 3, or just when in doubt, pick C. No, don't do that tomorrow. When in doubt, pick C doesn't always work. But remember, the confidence interval, so a confidence interval, I'll just write it like this, like the middle 95%. The middle 95% fall within like the mean, and the theme is plus or minus 2 standard deviations. Okay, so like that's what I'm thinking about. See, like, let me get the calculator open, and we'll just type this in. So here, I'm just taking, let me go switch back to real numbers. So I was in A plus BI, but I'm going to write this in real number form. So the mean is 0.497, which the average being close to 50 is good, but the standard deviation is kind of like, you know, let's see, plus 2 times. Like, I don't think this is going to reach. So we have plus 2 times the standard deviation is 0.050. And then a little trick, I just go up to this, I press enter, minus, and I get this. All right, so let me just crop this. Okay. And I'll erase some of this other stuff. All right, so now let's think about everything. So our middle 95% is going to fall between 0.397 and 0.597. Okay, so that means any percent that goes outside of this is like an outlier, like it's something unusual. So if you think about 73 heads and 27 tails, that means like the output of the proportion of heads here would be like, this is like 73%. See, because it was done 100 times, 100 coin tosses, which would be 0.73. And then you look at this, notice that 0.73 is not on this interval. See how 0.73 is greater than 0.597. So that means this is unusual. Okay, this is an outlier. That means her coin is not fair. Okay, like I was saying before, if we got like 51 heads, that would be 0.51. And notice that falls on this space here. All right, even 0.58 would be fine. Okay, but if we have like the soonest that it would happen that it's no good would be 60. Like if we have 60 heads and we have 40 tails, that would be no good because that would be 0.60, which just falls outside. Okay. So yeah. 3, her coin is not fair. These questions are like, I want to say they're not easy, but they're easy if you know what to do. Like if you know the concepts and the rules, it's like, oh yeah, just plus or minus and ask yourself, does that number fall where it needs to? Okay. So this one, let's see. If this and this, which statement is not true? Oh, do we really have to go through all this right now? Multiply, add, subtract, divide. Ugh, that's a lot. That's like, yeah, this test was like kind of obnoxious. But I mean, whatever. This one's like more just tedious. So let's see. If we add, yeah, adding them, like let's say I check choice 2. G of C is this. And then I add C plus 1. And you see how I would get 1 plus 1 is 2. That's the first day of school. And then you got positive C and minus C squared. So yeah, like that one's true. So we want the one that's not true. Multiplying is going to be annoying, so maybe I'll save that for last. But let's say I want to verify subtraction. M of C minus G of C. But I have to put G of C in parentheses and then send the negative through. So that's going to be C plus 1 minus 1 plus C squared. 1 minus 1, see you later. And we got C plus C squared. So this is annoying. All right, dividing. Let's see why. Is dividing always true? All right, I think it is 4 though, from what I remember. So M of C is C plus 1. So you see this divided by G of C. Oh yeah, this might be the one. Let's see. So C plus 1. Be careful. Don't say C plus 1, C minus 1. This is 1 plus C times 1 minus C. Okay, and here, this and this cancel. And this is equal to 1 over 1 minus C. But you see, this is off by a negative. So this is the one that's not true. All right. Cool. That is it. So 8 is choice 4. Oh, I'll show calculator tricks, even though years ago they allow you to do this without a calculator. So, yeah, years ago it was like not that normal CDF stuff. This exam is the, oh wait, light work, blah, blah, blah. Wait, at useless account. Oh no, we don't like the exam? Are we just trolling here? I always appreciate troll comments, but hey, if that means it's useless, then you'll get 100 tomorrow. So I hope you get the 100. I'm counting on you. All right. So, all right, that wasn't my best artwork. That's not going to go on my refrigerator. Okay. So here is standard, distribution, whatever. So the mean height, the heights of women in the U.S. are normally distributed with a mean of 64 inches. And a standard deviation of 2.75. So that means like, kind of like in your head, you go forward 1 standard deviation, and that's going to be 66.75. All right, if you go another 2 standard deviation, I'm sorry, if you go another standard deviations, let me just fix that. I'll put that over here. You add another 2.75. Okay, so if I do this, this is going to give me, yeah, the 69.50 directly. Okay, so years ago, they used to give you nice values. So they're saying here, the percentage of women whose heights are between 64 and 69.5. See how that's like from the average to forward 2 standard deviations. But what we were just saying before is that if we go backwards 2 standard deviations, plus or minus 2 standard deviations from the mean, yeah, I might have to like reset this program. Maybe that will fix it, but I don't know. So if we do the mean plus or minus 2, that's 95%. But this is symmetric. So here, I just think 95 over 2 is 47.5. So in this space here, this is 47.5%. So to the nearest percent, that would be 48. Okay. Oh, at useless account, I have the January Regents from last year like on YouTube. So you're always welcome to just watch that. I don't think it makes a whole lot of sense for me to make or do a live stream on something I already have like a full video on. So yeah. That's my, I think, yeah. So that's my, yeah, my motivation for doing this. All right, so, but I'll just say, try to do your best, people. Well, it's really just at one person right now at useless account. Please keep your comments, like, you know, as constructive as possible. Like, this exam is dumb. Like, it's a test, you know. Oh, thanks, Wild Pickle. I'm glad I was able to help. Yeah, Wild Pick. I saw that there were some questions on the test that were kind of reminiscent of what we did on the review. So I'm glad that, you know, that happened. So I'm happy to help, and I appreciate you coming on, you know, to say hello and thank you. All right, so is it second? Yeah, second vars is the trick. Okay, so second vars and then normal CDF. That's number 2. So the lower here and the upper is basically like how far, you know, up or down we're going here on the list. So what I want to look at here, our lower, we're looking at 64. Okay, and then let me just make sure I'm typing this nicely. And then the upper from 64 to 69.5. And then here, what we have is our average, okay, a mean of 64. And our standard deviation is 2.75. Okay, so I'll review that once more, just making sure I'm doing this. Okay, so it is right. Okay, so 48%. So I'm just going to review that once more. Second vars, normal CDF. So your lower is like, you see how they're saying between this and this? So that's your lower and that's your upper. Okay, it's from here to here. And then they'd say this symbol here is the symbol for the mean, the average. And then that's the symbol for the standard deviation. So you just type all that in and you just press enter. Now, the reason why this method is probably your best bet is they no longer give you like exact standard deviations. So yeah, that's like why you need to know this calculator trick. Yeah, that's like my idea. All right. So that trick, once again, is mainly when they give you something where like it's not like a integer, you know, standard deviation. If it's like a decimal, yeah, that's what I'm getting at. Oh, at useless account, you're taking AP Calculus AB. Very nice. That's a good class to take. I teach Calculus BC, so maybe when I start doing, oh, raise my volume. You could barely hear me. Am I sound coming in okay? So yeah, I don't know if maybe other people have problems hearing me. All right, so here we go. No, I know he's trolling. All right. Oh, so we have our Algebra 2 troll with us. All right, but you know what? I had some people on yesterday that I had to mute like permanently because they were saying really not nice things. But useless account, you seem nice behind it all. All right, I'm glad you're taking AP Calc if you really are awesome. All right, so the formula below can be used to model which scenario. So here, anytime you have this is a recursive formula for one. So this is recursive. And what that means is just keep multiplying the term before by the same thing. So this is like also geometric. And when something is geometric, it's also exponential. Okay, so that's what I'm thinking of here. And when we do this, so we have something exponential. We're multiplying by 0.80. So now I think of like, I don't know if you remember this formula from Algebra 1. So A equals P times 1 plus or minus R to the T power. But notice it's like less than 1. So this is a situation where we're subtracting R. And so that tells me this is going to be like kind of like an exponential decrease. Okay, so this exponential, but it's going to be decreasing. Or you could say exponential decay. So looking at choice 1, like I'm seeing like, all right, choice 1 is no good. The first row has 3,000 seats. Sure, A sub 1 equals 3,000 would match this. Like this part's okay. But each row after has 80 more seats. That's not what's happening here. We're multiplying by 0.80, not adding 80. All right, 1 would be good if you had this. And then you had A sub n equals the one before it. But then plus, oh, minus 80. Fewer seats. So minus 80, okay? So minus 80, so 80 fewer seats than the row behind it. All right, so that's like what I'm thinking here. But if we go last row even, it's like, it's kind of like we're starting with n. So this question just altogether is just like, yeah, like that one's like just not, oh, I'm sorry, I was reading choice 2. Forgive me. The first row has this, and each row thereafter has 80 more seats than the row in front of it. Choice 2 is also no good, because here it's like they're saying the last row has 3,000 seats, but we would need the first row to have 3,000 seats. So that's out. All right, 3, a bank account starts with a deposit of 3,000, and each year it grows by 80%. No, growing by 80% would be 1 plus 80%. And this would be multiplying by 1.80. Okay, but notice we're not multiplying by 1.80. We are multiplying by 0.80. So this one here, the initial value of a specialty toy is 3,000, and its value each of the following years is 20% less. So that would be an R value of 20%, which is 0.20. And if you use this formula, the 1 plus or minus R, 1 minus 0.20 equals 0.80. Okay, so if it's reducing by 20%, reducing by 20% is the same thing as multiplying by 80%. So that's why it's 4. All right. Let's see. All right. So moving on. Sean's team has a baseball game tomorrow. He pitches 50% of the games. Okay, so here we go. So Sean pitches 50%. All right, so he pitches pitches 50%. There is a 40% chance of rain during the game tomorrow. If the probability that it rains, given that oh, it's Sean, not Steven. All right. Sean pitches 50% of the games. There's a 40% chance of rain. And if the probability that it rains, given that Sean pitches is 40%, it could be concluded that these two events are independent. Okay, Sean pitching has no effect on the weather. That would be insane if Sean pitching just makes it rain. Yeah, not a metaphor here, like literal rain. Okay? So this is independent. Dependent is not the case. All right, so dependent would be like the only way it could rain is like if Sean pitches. So that's not it. Mutually exclusive would mean like they cannot happen simultaneously. But yeah, Sean could be pitching and it starts raining. It's not like those events can't happen simultaneously. So these are not it. Okay. And complements of each other, that is, these are not complements of each other here. That's like saying like, oh, it's a 50% chance that Sean pitches, and then the rest of the percent is the percent of rain, and they're like linked together. that's not the case. Complements would be like think of a dice. So we have a dice, and it's like, I don't know. I'm bad at, drawing these things. Okay, so if we have a dice, it's like, what's the probability of, let's say a 5 or higher? That's, 2 out of 6 or 1/3. The probability of getting a 4 or lower would be 4 out of 6 or 2/3. So you see how like these are complements because they make up the entire space. All right, so independent is when the probability of like one thing happening has like no effect on the other thing happening. Like here, it's just kind of an obvious answer because like, yeah, Sean pitching is not going to affect the rain at all. See, he pitches, there's a 40% chance of rain, and the probability that it rains given that Sean pitches is equal to 40. It's like, yeah, not doing anything. All right. Wait, the logic based. It's definitely logic based, that one. All right, a solution of blah, 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 blah. So this one here, you could just use the quadratic formula, or you could use the calculator. So here, like what we could start doing is we could go back to a plus bi. And let's say I write in the first one. So negative alpha y equals enter makes a fraction. I'll show that again. Plus alpha y equals enter. And then you got 1/4. Not 1. Times I is second decimal. And then square root 7. So I do this. I press enter. And I press store as alpha math. I store it as the letter A. The reason I do this is because now I could just write 2 times a squared plus 3 times a plus 2. And it's 0. So right away, it's choice 1. Okay. Yeah. All right. Cool. Moving on here. All right, let's see. So, actually, you know what? I'll show the quadratic formula. So we'll see this with the quadratic formula. So we're going to have a is equal to 2. B is equal to 3. And C is equal to 2. So here, if we use the quadratic formula, remember, it's x equals negative b plus or minus the square root of b squared. And I don't have to put parentheses here because b is positive. Minus 4ac all over 2 times a. And now I have negative 3 plus or minus. That's 9 minus 16. And that's going to give us negative 7 under the square root all over 4. And now this is negative 3 plus or minus. The negative inside of a radical of a square root could pop out as I, like this. And then now you could break this up into 2 pieces. This is negative 3 over 4 plus or minus. And now here, there's an invisible 1 in front of the I. I could say 1 over 4 times I radical 7. And you see how this one here is definitely it. All right, so that is our solution. All right, 13, we could use a calculator for this. So this one is a nice question because it kind of relates circular motion to the trig functions, how it's, there's like a really cool Wikipedia thing that shows the link between the unit circle and the sine and cosine waves. So yeah. All right. All right, let's see here. So what they're telling us is the Ferris wheel. So here's our Ferris wheel. All right, so there's the Ferris wheel. Is in Chicago. It takes 7 minutes to do one full rotation. The height h in feet above the ground. So you see, like at any point here, like this distance we're calling h. So from here to here, you know, from let's say here to here, like it's depends on like where we are on the Ferris wheel. All right, we see like it's minimum, increasing, maximum height, decreasing, minimum height, increasing, maximum height. But they're telling us that the height in feet above the ground can be modeled by this, which makes sense that there's a plus 80 at the end, because that's going to affect like where the midline is. I'm just thinking here, like, all right, it's going to start 10 feet above the ground. Okay, and it's going to go, yeah, it's going to go like the amplitude is 70, but it's like from the midline. I'm just thinking out loud. But now if you know your formulas, the 70 is the amplitude. Okay, the next important thing that you need to know here is the midline. The frequency is less important because we're not actually graphing this. Like we're not graphing this, like we really just need to know the car's minimum height. All right, so like if you really know this concept here, like this answer jumps out, and I'll show you why it jumps out. The midline is the value at the end. The plus in this case is 80. So now I'm going to move this out of the way, and then I'll show you how to do this with the calculator. Okay, but if we look here, what we have is the midline is 80. So I'm not drawing this to scale. Let's just say that's 80. And now the amplitude is 70. That's the distance from the midline up to the highest point, or the distance from the midline to the lowest. So here I would go 80 plus 70 is 150. Okay, so you see like I'm going plus the amplitude. I'm going plus 70. But I also go minus 70, and that brings me down to 10. So this curve, like I'm not necessarily going to draw this where it's shifted horizontally too. The frequency's all out of whack. But like whatever it looks like, it's going to do like something like this. Okay, which means like the minimum height is going to be at 10. All right, which when you think about it, yeah, once again, like we're going plus or minus 70. That makes sense in the context of the question that the Ferris wheel doesn't scrape along the ground. That would be insane. Okay, like you could see like the height increases, goes to a maximum, and then it starts to decrease. It decreases to its minimum, and then it goes back up again. And that's the manner in which it increases. Okay, so the minimum height is going to be 10. All right, that's without a calculator. With a calculator, make sure you're in radians. Okay, I'll switch back to real. Don't think that's going to matter, but just in case. And now I'm going to clear this out, and I'm going to type everything in. 70 sine. We've got alpha y equals enter. You've got 2 pi over 7. And we've got t, we're going to use x, minus 1.75. We close the parentheses around this. We close it around the sine function. Then we write plus 80. But watch what happens. We graph this. And we're like, I can't see anything. All right. And the reason being, if you go to the table, you see like the values are going way, 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 way up. Now, I'm using what I know. I know this is going like up to like 150. But let's say I go, just to be safe, I go to like, let's say 200. Okay, I go like this. And then I look and I say, all right, well, what's the minimum? I could just press second trace 3. And I could trace any one of those minimums. Okay, so like maybe I trace that one. Like I like that one the most. So I hit enter before the minimum. I hit enter after and enter a third time. And you see the minimum is at 10. Okay, so that's the minimum height. If I want the maximum, second trace number 4. Okay, you can get it this way. But you knowing the trig formulas and how to graph those things by hand with like all the shifts, see the y equals 150. And then 3.5 is getting into like when it hits the maximum height. All right, so that's all right, cool. Let me see. Oh yeah, I'm just trying to pay attention to the chat. Well, useless account. We're really, what do we got going here? Hope you're being nice to everybody, I hope, right? All right. Remember, if I have to, I can mute people or put you in timeout. So just make sure you're nice. As long as you're nice. So far, you're like, right, like, you're at that. Like, you're not saying it. Like, some people yesterday, I just basically booted. So, yeah. But don't be a troll. People are here to learn. Like, let's make the chat, like, somewhat productive. All right. I'm not a troll. All right. Fair enough. If that's it. What you think of yourself. All right. So here, let's see. We have this expression is equivalent to. So this you could just do polynomial division. But remember, if you're like really like just wanting to mod power, I am sorry, useless account. I am not going to give you mod power, but yeah, that's not happening. All right. Let's see. So y equals, if you had to, all right, this is like, I don't want to do algebra. I just want to pass. So if you just want to pass, it takes time, but you have 3 hours. You could just start typing in the function. I'm sorry, not the function, the original expression. And then you got 2x plus 3. Okay, and then the answer, spoiler, is 2. So I do this, minus 3x plus 7, and then minus alpha y equals enter, pulls up a fraction. And I like teaching students this because then you don't make any like parenthesis mistakes. And you see we grab this and the answer, and they overlap. So that's how we know. Oh, at iTesky. I'm sorry you're having a tough experience in class. I usually like I won't join in like on talking about the teacher, although you're painting a very like funny image of like someone like I imagine if I just ate donuts in the front of the room and like yeah, just doing delta math. I do delta math for homework, like not gonna lie, but in class I'm like teaching. But sure, why not tell a story about donuts? One student, I remember it was like one of the coolest things a student ever did. One of my students from like 7 years ago, he was in AP Calculus. He showed up to my test with 4 donuts. And I'm like, oh, cool, you got donuts. And he's like, yeah, I had a dream yesterday that I just brought you donuts. And it was kind of a cool dream. So, like, here are 4 donuts. And I was like, awesome. And, like, back then, I was like, I love sugar. And while they took a test, I just ate, all the donuts. And now anytime I hear donuts in the context of school, I just always think of that student. It was, like, one of the coolest, one of the coolest things. So, yeah, that's, those types of teachers should get fired. Oh, you're breaking... All right. I mean, look, I don't know. I don't want to join in like bashing like that's because like, I work with a lot of teachers. Like I just, but I know students like you have your own opinions of who your teachers are, but I'm sorry if you're not enjoying your class. I'll do my best to make this like informative, but, you could be the teacher, useless account. You think you could handle running the show? I don't know. Teaching is not as easy as it looks. You know more than me. Oh, maybe. Maybe you do. 2x squared times 2x is 4x to the third power. And then 2x squared times 3 is plus 6x. Now, sometimes what students will like to do with this. So, all right, so here we are. This is optional. But some students like to do this. And I would say, like, if you get nervous with this process, you've got 0 x squared like this, and then plus 5x. You could put a placeholder, okay? Oh, wait. Why does it say... Oh, my bad. Because that's a good thing to point out. Hang on a sec. Thank you for someone for noticing. Algebra 2, it says now. Thank you for that. Oof, that means yesterday's. Yeah. All right, let me just see. I'm going to put, yeah. Going to put, all right, I'm putting, yeah, useless account. I'm putting you in a timeout. All right, 10-minute timeout. See if our friend could behave when he comes back. All right, going back to it. No, but hey, I mean, I guess yeah. As long as I have been doing these streams, I get a few trolls every time. So, what would you recommend if you don't understand the short response? Yeah, I just muted them. Yeah, so they are. I just deleted like 500 messages. So yeah, they're quiet now because I want this to be like not it's breaking my concentration, and if it's breaking everyone else's, then yeah. So if you struggle with the short response, you can use the calculator to kind of help you along. So I would say if you struggle, like just do your best to put something down. Don't leave it blank. And you could use the calculator. I'll show you when we get to the to that section. All right, so we have this, and then plus 6x squared. Yeah, you know what? I think I'm just gonna. I feel like they got enough heads up. All right, I'm just thinking out loud. All right, so here now I subtract. So minus minus, this is gone. We get minus 6x squared, and now I bring down the 5x. And now here I have minus 3x. So what I'm doing is I'm just dividing each term. So you see, like when I get a new leading term, I'm dividing it by 2x, and I get minus 3x. Okay, and then now I work this out. Negative 3x I multiply by 2x is negative 6x squared, and then negative 3x times 3 is negative 9x. But now what I like to do is when I subtract, I go minus. If I subtract this, I have to distribute the minus, and that changes both of these to plus. Okay, so like that's really what's happening is like you're distributing a negative across to what because you're subtracting this from this. So now these cancel, and 5 plus 9 is 14. So I get 14x in this row. And now for plus 10, I do one more line of division here. I have 2x going into 14x is going to be 7. Okay, so 7. And then 7 times 2x is 14x. And then 7 times 3 is 21. But I'm subtracting here. Okay, so when I subtract, I'm going to have minus, minus, and then 10 minus 21 is minus 11. Okay, so minus 11 over 2x plus 3. All right, so that's where we're going. Cool. Oh, Jake, how you doing? Can I help you with physics? I mean, maybe at the end, if I end early, I could try to answer 1 or 2 physics questions, but I'll be honest, I'm very rusty. I haven't taught physics in like 5 years. So, if you have like Regents questions you want me to look at, like I could try to help you on 1 or 2 at the end. But yeah, that's going to be a little while. I got a lot of questions to get through. All right, 24, multiple choice. So exponential decay, 2 things come up. I think of this, that's what it looks like. And I think of like y equals a to the x, where a is some number between 0 and 1. So this is no good. The reason why I know this is no good, like without a calculator, is that this is the same thing as like 2 to the 0.3. And then this is to the power t. All right, and I know that this is greater than 1. So if it's a greater than 1, like if I have y equals ax, where a is greater than 1, it's going to be exponential growth. All right, so that one is not going to be it. How many questions on this exam? I think it's 36. Let me see. 37 questions. All right, I'll speed up a little bit if I need to. And if people need me to slow down, I will. So I know this one's not it. This one also is not it. 1.2 to the 3 is bigger than 1. And now it's between these two. It's already, I could see like looking like choice 4, because this is the same thing as 5 over 1 to the negative t. And the rule with negative exponents, when you have like a to the negative b, that's the same thing as 1 over a to the b. Okay, so this I could have even just used that rule right away. Actually, now I got to write that whole thing over. All right. So a to the negative b is the same thing as 1 over a to the positive b. So this is 1 over 5 to the t. Okay? So, yeah. So this would be the one, exponential decay. This one, the problem is if I flip it, then it becomes 2 over 1 to the positive t. So this is also exponential growth. If you had to, though, once again, the calculator is one of your best friends, at least tomorrow. You could just type it in. You could type in 5 to the negative x. Put this for your negative, though. Please don't put the subtraction sign. So I presume 6, and you see that's exponential decay. All right. All right. Oh no, I got to mute someone else. I have a feeling like they're related. All right. Yeah, no, I'm from now on I'm just muting trolls. So all right. Also muted. All right. So moving on. Yeah, they're tell me this guy has like 48 responses. Yeah. Yeah, from now on I'll just put that in the rules. Any trolls from here on, I'm just going to mute you. So all right. So here we have the inverse function and we want to find the original function. So this is when you switch x and y. And then you solve for y. Okay, so here, what I'm thinking is I'm just going to say x equals negative 3/4 y, and then plus 2. And I'm solving for y. Just pretend that says y equals instead of, yeah. Oh, Ryan Tube, I'm glad. Thank you. I'm happy to help. And thank you for being like, you know what, Ryan Tube, because you've been here so long. Hang on a sec. Yeah, hang on. I'm just going to write thanks because like right now my chat is being funny. Thanks. But I'm going to make you a moderator. I'm not giving you a job, but you have been so great for however long now. It's been like, what, like over a year, or around a year or so, maybe longer that I have been talking with you. So you have the power. You don't have to stay. I'm not telling you to watch the whole time, but if you have my permission to, use admin power as you see fit. Okay. So cool. All right. So here, what we're going to do is we're going to go -2. This is going to cancel, and we have x minus 2 equals negative 3/4 y. Yeah, no, you more than earned it, Ryan Tube. So you have my permission. If anyone trolls, but it's like harmless, like, we could give them a polite heads up. Or if they're like really overdoing it, then we'll give them the boot. Now look, dividing by negative 3/4 is the same thing as like multiplying by the reciprocal. So you see, like, I could just do this all in one shot. And I'll just write it like this, like multiply by negative 4/3. Okay, and I do that to both sides. Because a negative times a negative goes positive, and you see like these things just like cancel out. Okay, so this like all cancels out. And it says y equals, and now we distribute negative 4/3 x plus 8/3. Okay, so negative 4/3 x plus 8/3, just double checking, is, yep, choice 2 is our answer. Cool. All right. A circle centered at the origin has a radius of 10 units. So draw. All right, so there's our circle. The center is 0, 0. radius. The terminal side of an angle intercepts the circle in quadrant 2 at point C. So here's quadrant 2. Let's say point C is over here. The y-coordinate of point C is 8. So this is going up to 8, even though like up here is 10. Okay, so the x is a mystery. So it's like whatever this point is, like this is the point x comma 8. To get there, we go over x, and then we go up 8 units. Okay, and then here is our right triangle. All right, and then this is our reference angle. Okay, our full angle theta is the angle from standard position. Standard position is the positive side of the x-axis. This, once again, there's like a little r here, is our reference angle. So what we're going to have here is if I draw this triangle, out to the side, I'm going to put it over here, is we have 8. The radius is 10. So that's the distance from the origin to the circle. And now if you know your Pythagorean triples and you know your geometry, think of a 3, 4, 5. If I scale this by a factor of 2, it makes a 6, 8, 10. So they're almost like suggesting here that you should use this. So you see how like this here would be 6. But the x coordinate, notice I'm going to the left. So x here would be equal to -6. So that would be the coordinates. But they want us to know what is the value of cosine theta. So for this, you should know ASTC. Okay, ASTC. If our point terminates in quadrant 2, that tells us that in quadrant 2, only sine and its reciprocal cosecant are positive. All right, in quadrant 1, all of the trig functions are positive when you plug in an angle. So like what this means, if I took like 30 degrees, cosine of 30 is equal to square root 3 over 2. Sine of 30 is equal to a half. Tangent 30, the calculator will tell you all this if you go into degree mode. Tangent 30 would be equal to radical 3 over 3. But notice they're all positive. So if I plug in an angle from quadrant 1 into the trig functions, it's going to give me all positives. When I plug into... I would like to apologize for my language. All right, useless account. I'll give you the benefit of the doubt here. But if I see that again, I'm just going to mute you permanently. All right, so please keep it real while you're here. All right. So, and that was it Rocco 2K. Thank you so much for the tip. I appreciate the tip here. So thank you. Yeah, so I've given admin power to people in the chat. So once again, keep it real or you will be muted permanently. Okay, cool. So looking at this situation in quadrant 2, only sine and its reciprocal are positive. So when I'm finding cosine of theta, I know that it's going to be negative and then cosine of my reference angle. Okay, and cosine of my reference angle, I have negative. Adjacent to my reference angle is 6 over the hypotenuse, or remember the radius of the circle is 10. This distance is 10 over 10. So this will make -3/5. Okay. So that's like really it for that one. If you want to do this a different way, so another way you could do this is you could go to the main screen and what we could do is we could take the information we have now, like you see how this was 8 and 10. So that would be opposite over hypotenuse would be sine. If I do the sine inverse, second sine of 8 over 10, that's my angle in quadrant 1. But if I do 180 minus, this would be the quadrant 2 angle. This is the exact quadrant 2 angle. And then we want to know what is cosine of that angle. So cosine of that angle is this, and then press math, enter, enter, -3/5. All right, that might be easier to work with. So, all right. That's, yeah. So what you could do is you could find the angle but then find the quadrant 2 one, treating this as a reference angle, and then plug it directly into cosine. All right, which statement about this graph is false? So, calculator, how do you graph log functions? So go to y equals, press math, go up, option A, log base 6, okay, of x, and we press graph. And it looks something like this, but what I'm going to do is I'm going to zoom in. I'm going to go like starting at 0, or maybe -1. I'll just get close. And we'll go up to like 5. And even here, like I could probably get a little bit closer. So maybe I'll go like, I don't know, -5. The point is like, I just want to get a better idea of what's going on. And I just keep zooming in more and more. I make like my x maximum 5. Another thing I could do is like, let's say I go back to normal. Like I know I'm just messing around with the window. You could press zoom number 1, zoom box. And then you treat this like you're cropping a photo. You just press enter. You scroll down. You scroll over. And you press enter, and it'll graph just that portion. Okay, so this is really, once again, just to get a nice picture of like what's actually happening here. All right, so this is our graph. All right, now what we have is, for log functions, the domain, the inside of a log has to be positive. So we have a vertical asymptote on the y-axis, like this, the line x equals 0. And it's going like this. So now which statement is false? The asymptote has equation y equals 0. Y equals 0 is the x-axis. So that is the x. And that is not an asymptote. So this right away is false. The graph has no y-intercept. Yes, x is always greater than 0. This never hits the y-axis. The y-axis is an asymptote, so it's not going to hit the y-axis. The domain is the set of positive reals. Yeah, x is greater than 0. That's the positive reals. That's true, and the range is the set of all real numbers. This drops all the way down. Okay, so this is going to drop all the way down, and this is going to go all the way up. Okay? So, all right. So let's see. Now we have this equation here. The equation blah, blah, blah is equivalent to. Ooh, all right. This one was like definitely. How do you know if an asymptote is horizontal or vertical? All right. So at Eliana Singer, good question. You just kind of, like if I have, I'll look at a few other examples. Like y equals e to the x. Looks like this. So in this case, you see how it looks like the function is landing on the ground. If it looks like the function is landing on the ground, that's a horizontal asymptote. It's like getting, like it's dropping to a certain point like this. All right. Whereas in this case, you see how it's like, it's heading towards a vertical line, but it's not going this way. Like it does this. Okay. The y value, the function goes to plus or minus infinity. So how do you know if it's vertical or horizontal? So for a vertical asymptote, what happens is the function goes to plus or minus infinity. Okay, the function, by function I mean like this, I mean the y value. Okay, whereas like for a horizontal asymptote, the function approaches like L, where L is like a number. Okay, as x goes to plus or minus infinity. Like you see here, like as x is going all the way left, the y value is heading towards 0. Like here, we have a horizontal asymptote at y equals 0. The y value is getting closer and closer to 0. Yeah. So, all right. So I think, yeah, useless account. I'm just going to keep their comments hidden because they're just like, yeah, I don't know. I just feel like not liking the vibe. All right. So please, yeah, once again, keep it real in the chat. But I think they had enough chances. Yeah, RyanTube, not to like go over your new admin power, but yeah, I'm just, I don't know. I feel like doing this job for a while, I kind of know when someone's going to just keep at it. And I think we could use a break. All right. So moving on here, we have this equation is equivalent to. So this one is, you could use completing the square. I did this and it was like kind of ridiculous what I did. I'm almost curious, like, is there a much easier way of doing this? And there might be, but all right, I'm just going to complete the square. So I take this and I'm going to factor out a 4. And what do I have? X squared minus 6 times x. And I'm going to leave a space. Okay, I'm going to leave a space here. And now this part, so I have this plus 4 times, and now I have y squared plus, if I divide by 4, I'm going to get 18y. And now I leave another space. Okay, and this is all equal to 76. All right, so everyone see, I just factored out a 4 from both of those. You know what? I'm actually going to, I just noticed an easier way of doing this. I'm sorry if you copied this. I'm going to factor out a 4 from everything. Yeah. I think this should work. I'm curious. If it doesn't work, then I'm sorry. You'll never get those seconds back in life. But I'm going to take a 4 out of everything. All at once. So you all see that? This is what I'm doing. I think this is going to be easier. Then I'm going to divide both sides by 4. Oh, wow. This guy has like 40. He just keeps making new accounts. All right. Yeah. All right. It's going to be a hard job for some. But it looks like we have a very persistent troll that's just really doing their best. So, all right. I'm just going to be practicing. Oh, yeah. So at Rocco, thanks for the tip again. And thank you for watching. Good luck tomorrow. And yeah, I wish you the best. All right. Thanks for stopping by. All right. 4 goes into 7 once with the remainder of 3. So 19. All right. So now we simplify this a bit. And now we could complete the square. So b, half of the b value squared like this. So what we have is -6 over 2 squared is equal to 9. So you see that, like, our b over 2 squared, our b value is -6. Half of that is -3. Squared is 9. So I'm going to go plus 9 on both sides. And then my other b value is 18. I divide that by 2 and square it. And I get 9 squared is 81. So I'm going to add 81 to both sides as well. All right, this will have a point here. So let me just see this one. How is this one going to? Oh, but you know what? I'm sorry. The first way I did this was the way. I'm sorry. I tried to experiment here. Although, wait a minute. I guess I could divide all of the answers by 4. It'll still work this way. All right, but I should do it the original way that I intended. I just thought this would be easier. All right, so this one is going to make x minus 3 squared. Plus, this is going to make y plus 9 squared. So you see how, like, that doesn't really help us because, like, they all have that. All right, equals, and now we have 90 plus 19. Okay, which is this. And now, but notice, like, all of the answer choices have a 4 in front. So, like, maybe now I just multiply everything by 4. Okay, and this times 4 is 436. I mean, I guess that was maybe easier. I don't know. We just had to pay it back at the end. Yeah, this could definitely show up SAT math. A bunch of this. Not the questions that take crazy long because you don't have 3 hours for the math. But yeah, that's something that is possible. All right. So here we go. Question 20. There was a study done on oxygen consumption of snails as a function of pH, and the result was a degree for polynomial function whose graph is shown below. Which statement about this function is incorrect? The degree of the polynomial is even. All right, so now I'm just moving on here to this. Like, let's say you're looking at this like, wait, what does it mean to be even? Even if the polynomial's degree is even, that just means like it's the highest power of x that shows up in front. But they said the result was a degree for polynomial. So 4 is even, the degree of the polynomial is even. Like, that's a true statement. That's not incorrect. Okay. No, Ryan Tube, don't worry. Like I said, I gave you that power. For my future live streams, like I'm gonna see like who I recognize. Like, I recognize you and I recognize Fortnite. There's a few people who like I see a bunch. So as I recognize people more and more, and I know you're like, you know, here to learn and you're like really for the community, I will give you admin power to expel the trolls. All right. That's not a one-person job. All right. But I appreciate you. You did moderate. All right. You did like send some messages like, hey, don't be a troll. And I appreciate you for that. All right. Unfortunately, yeah, there are people who go on YouTube just to derail the instruction. And hey, I guess that means like the channel's doing well. If you don't have trolls and people trying to throw it off, then you got to be doing something wrong, right? So, all right. There is a positive leading coefficient. Now, this one, notice that it's a polynomial that's opening downward. So the leading coefficient here is not going to be positive. It's going to be negative. And the reason being, like how I know it's going to be negative, if I have like negative x to the 4 plus blah, 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 the leading term, if the power, like the leading term here is a 4, but if we have a negative in front, that means the end behavior, like if this were not a real world situation, that the function would drop to minus infinity on both sides, left and right. All right, so that's how I know like it's choice 2. For choice 3, at 2 pH values, there's a relative maximum value. That just means there's like 2 hills, all right? A relative maximum means like if I have this, are like the hills, okay? Like the high points in the neighborhood. And you can see here, we have one here and one here. All right, so those are the 2 maximums, local maximums. There are 2 intervals where the function is decreasing. The function is decreasing here, and then it's decreasing here. So yeah, 2 intervals where the function is decreasing is true. So it's got to be this one. All right, and you could even see if you have, let's say, something like negative x to the 4, it does not matter what you write after this. Okay, if you write like plus x to the 3rd, whoops. So we write plus x to the power 3 plus x to the power 2 plus like 1, and I press zoom 6. See how like it's just dropping like this. So you could always try. Oh, thank you at Ryan Tube. I appreciate you spreading the word. And to anyone else, yeah, if you help spread the word, I appreciate it. Or if you're just watching for yourself, you know, I appreciate you all for being a part of this. It really does mean a lot, seeing how well these live streams have been doing, reaching lots of people. So thank you all for being a part of this. It really does mean a lot. Okay. So let me just see if I could report. Okay, I'm just reading something here. Okay, moving on. So last year, the total revenue for Homestyle, a national restaurant chain, increased by 5.25% over the previous year. If this trend were to continue, which expression should the company's chief financial officer use to approximate their monthly percent increase in revenue? Let M represent months. Okay. So here, what I'm imagining is like we're multiplying. So what's happening here? 5.25% is 5.25 out of 100. And it's equal to this. Okay, so like these are looking good. And remember, it's that same idea as this. But I mean, you can think of this as like, how do I say it best? I mean, I'll just write this one for now, because this one, like the algebra is a little abstract. So my first instinct is to do 1 plus the rate. So 1 plus this is 1.0525 to the t power. And from here, what I would do is I think about it. T, though, this is like compounded annually. So t would represent years. But think about it. If I have t years and I want to convert this to months, I would multiply, there is 12 months in 1 year. All right. And I'll just say years, even though that doesn't sound grammatically correct. So if I have t years, that's 12 times t months. Okay. So like there is going to be a point to this here. Okay. So t years is equal to 12t times months. Now, I'm trying to think about how to make this as nicely as possible. How do I make this simpler? Because then it's going to get a little, yeah, you know what? I'm going to explain it a different way. Because the way I do this, like I kind of just do some like weird math in my head and I just get to the answer. Like basically I know like I have to like in a way like, you know, divide by 12 and then multiply by 12. So like, all right, this is what I'm doing. I'll just show you what I do. I mean, why not? I'll just show you the way I normally do these. So what I'm doing is, once again, if I have t years and I say this is equal to like, you know, 1 year is equal to 12 months. What I'm going to do is I'm going to raise this to the 1 over 12 power. Okay. And then I'm going to multiply by 12t like this. Because what I was just saying before is like, once again, 12 months is equal to 1 year. I guess I should have left what I had. So 12t months is like how many months we have. All right. So this is what I want. I want the 12t. I guess, yeah, that was the right approach. I just, this is what I'm creating. So really what you do is you just write like 1 over 12 and then to the 12t. And then this, the calculator is going to tell you. Okay. So this is going to tell you, and these are the only other decimals that show up. So if you do 1.0525 to the 1 over 12, it's going to give you this to the 12t power. But 12t represents the number of months. And they're saying here m represents months. So I could just replace 12t with m. So that's why here this is going to match up with choice 3. Okay, 12t is like the number of months. See, 12t months. So I could just say 1.00427 to the m power. All right, so that's the idea. Your Regents is tomorrow. Just want to pass. I'm rooting for you. All right. I'm cooked. I'm so scared for this Regents. It's your first time taking it. Good luck tomorrow. Yeah, no, I know people are nervous here. But just, you know, do your best. All you could do is like really what you're doing right now is prepare and then do your best to show up and, you know, see how you do. Which value to the nearest tenth is not a solution of this if this equals this? All right. So this I would just honestly do in the calculator. Don't do this by hand. So y equals, and you've got x to the third plus 3x squared minus 3x minus 1 over 3x plus 8. I'm sorry, equals 3x plus 8. So we want to see where p of x equals q of x. So if I graph this, like I might be able to see it, but I'm going to show you another trick. Second window, change the independent from auto to ask. And if these equations are equal, when I start typing in those x values, see how here I could see right away, is this one, which value to the nearest 10th, wait, maybe I made a typo here, x to the third plus 3x squared minus 3x minus 1. So which one here is not a solution of this if this equals this? I'm just making sure I didn't write anything crazy. No, I think we're good. Okay, so I look at the table, and now I've got negative 3.9. Let me see this, negative 1.1. What's going on here? Something's up. I feel like yesterday this was working much nicer. Something's out of whack right now, because these are like all not working out. Which one is not a solution of P of x equals Q? Let me just double check. X to the third plus 3x squared minus 3x minus 1. Q of x is 3x plus 8. Let's see here. Maybe if I do this. Let me go window up. Because I did this yesterday and I got it to work nicely. But something's acting funny right now. Second trace 5. Maybe if I trace the intersection of these two. Negative 3 point. Okay. Wait a minute. Oh, I see. Like, I guess they're, when they round, it's like, all right. So this is the way. Second trace 5. So tracing the intersection is the best bet. Yeah, that's it. Okay, so I'll just do it this way, and then I'll explain what I'm doing. So we have this. I hit second trace 5 to trace the intersection, because the intersection points where the graphs overlap is the solutions. Enter 3 times. And I get this. And then the last one, second trace 5. Yeah, so plugging in is like not the way here. Your best bet is to just trace the intersections. And you see how I get 3 answers. I get x equals negative 3.9 if I round to the nearest 10th. It's the fact that it was rounded is why. All right, because I'll show you. Like if you don't round, like watch this. If I don't round, like let's say I hit, watch this, second mode, second minus to get the answer. And I store that as alpha math. I store that as A. Now I go to the table, and instead of this, I hit alpha math. Okay, you see how these, like instead of 2.1, it gives me like the exact decimal, and then my y values match directly. All right, so that's why it was like not working out, because the answers are rounded. All right, so that's why it was no good. But what you do is you get your intersection points, and then you just round them to the nearest 10th. So this would be x equals negative 1.1, and this would be x equals 2.1, because that 5 tells us to round that to 2.1. And then you're like, all right, that's an answer. That's an answer. That's an answer. So you're the culprit. That's not it. All right, cool. Let's see. The population of Jamesburg, blah, 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 blah. How can the sequence be recursively modeled? So that tells me I'm looking for, like, if it's j sub n, I'm looking for a j sub n minus 1. So you're not recursive, but these two are. And now I just look for the pattern here. Is this an exponential or like a geometric? This one would be geometric. And this one would be arithmetic. Okay, so either way. And what we have here is, for this one, to see which one it is, what you could do is divide consecutive terms. So, I mean, you know, I could do something like this. Like I go on the main screen. From 250,000 to this would be plus 937. You see, like if I did 250. Oh, wait, this pen is showing up. Hang on, let me fix that. So 250,000. All right, 250,000, 937. Whoops, 937, and then minus 250,000. Gives me this. Like that would be the difference between those two. So if I add that to 250 and then 937, see how it doesn't match this? So I know I'm not just going to keep adding 937. Like, that's out, and it's got to be this one. All right. But now how do I know it's that one? Well, I can even just write this like kind of in the y equals. And I could say if I have, I mean, no, I'll just do it on the main screen. I don't need to write it in the y equals. I'll show you how to do that in the y equals, but you don't have to. So 250,000, 1, 2, 3, times 1.00375. And you see rounded, well, 259.37 is pretty close. And if I multiply again by 1.00375, 251,878, like, yeah, like this one's like the best one we've got. All right, so here, 3. Oh, finally, the last one. 24. 24 was really nice. I like 24. It's that frequency period concept. So the voltage used by most households can be modeled by a sine function. The maximum voltage is 120. Okay, so this might matter or it might not. And there are, here we go, this is big, 60 cycles every second. Okay, so if I put this as like, which equation best represents the value of the voltage as it flows through electrical wires, where T is the time in seconds. So T is representing seconds. Okay, so if 1 second goes by, just remember the concept of a period. The period is how long, so whoops. So this is, yeah, I don't know why this is not letting me, let me just switch to this mode. The period is how long it takes to complete a cycle. It takes to complete just 1 cycle. Okay, so if they tell you that that it completes 60 cycles every second, that means if this is the t-axis, like I can't even draw this. It's going to be like really ... like a lot. But that's 60 cycles in like is equal to like 1 second. Okay, so then how long will it take to complete 1 cycle? Right, and that didn't write properly. So for 1 cycle, I divide both sides by 60. And that tells us it's going to take 1/60, 1/60th of a second to complete 1 cycle. So now, when you think of a trig function that's in this form here, it's like y equals a times sine of bx. But here, like, instead of x, they use t. So a is the amplitude, and b is the frequency. And now just know that the frequency, to find the frequency here, we would say that the frequency is equal to 2 pi divided by the period. Okay, so just, yeah, remember that concept. So frequency is 2 pi over period. So considering that, and the period, just know, is how long it takes to complete 1 cycle. So 1 cycle takes 1/60th of a second, so the period is 1/60. And now we just plug in the frequency is equal to 2 pi divided by 1/60, which is going to change to 2 pi times 60, which is going to change to 120 pi. So here, do they tell us the maximum voltage is 120? So that's our amplitude. So our y equals is going to be 120 sine, and then it's the frequency times t. The frequency is this, is 120 pi, and then times t. All right, tricky question. If you take physics, that's useful for physics also, knowing like frequency and period. All right, conquered the multiple choice. All right, so here, now let's just rip through these. Solve for x. So we got to do this algebraically to get full credit. So if you do it any other way, you get 1 point. But if you want to get full credit, the first thing I would mention is like the restriction. X cannot equal 0, because if you let x equal 0, it makes a 0 denominator. So just say that right away. X cannot be 0. And now, what I like to do for these is, one way to do this is to find the least common denominator, which are like all the factors like other than 1. So there's a 3 and an x, so 3x. And now you can multiply everything by 3x. And you've got 3x over x. So I do this. And this notation's okay. Big parentheses around the whole equation. Minus 3x over 3 equals negative 3x over 3x. And now we've got 3 equals, I'm sorry, not 3 equals, 3 minus x equals 3x over 3x cancels and makes negative 1. And now here we just solve, plus 1 on both sides. So you have 4 minus x equals 0. And then add x, x equals 4. All right, if you have the time, check your answer, plug back in. But 1 over 4 minus a third will definitely equal negative 1 over 12. All right, I promise. Okay, so describe how a controlled experiment can be created to examine the effect of ingredient X in a toothpaste. So for this, I want to think about how to say this as nicely as possible. With the control experiment, you have one group called the control group, and they like remain the same. And then the experimental group is the one you give the drug to and see the difference between the two groups. Okay, so describe how a controlled experiment can be created to examine the effects of ingredient X in a toothpaste. So say make two groups. All right, and I'll say group A and group B. And say give the toothpaste with ingredient X. So let me just fix this. So with ingredient X to group A, and then give a, regular toothpaste to group B. And then analyze the results, say looking for differences in the two groups. All right, so that's what they mean here by a control experiment. All right, so analyze the results, looking for differences between the two groups. I would say that's fine. I could double check though, just to make sure I'm not missing anything. But I'm pretty sure that's fine, because it just says I guess when I threw this one together, it was just kind of all right, it felt like it was an okay solution. But let me just look at what year. Oh yeah, we're doing 2016, so June 2016, here we are. And I'm just going to check the rubric on this one. So 26, because these are I don't want to miss anything subtle. I'll just I want to be 100% sure that we're okay here. Oof, this person wrote a whole give random group an equal amount of toothpaste. Okay. Record the results to determine the impact. Yeah, so one group will use. Yeah, so here, maybe mention like the random assignment of two groups. So, all right, like make two groups, group A and group B, like say, like randomize, like make them like random as possible. Yeah, I just wanted to be sure. Just like sprinkle that in, like make it as random as possible. Okay, like that's really like all that's missing here. Like if you even want to say like with a big sample size so that it's like better results, like you could say that too. So like make two groups, like 40, or let's say even like how about 50 people each. So that's something that could like enhance your answer, but as long as it's like random, like it's fine. All right, yeah, those questions are like kind of annoying. That one's like more of like an I gotcha question, but I just wanted to focus, I guess, on moving along here. But I'm a stickler for like making sure what I put out there, like I mentioned all those like rubric details that you don't miss out. All right, determine if this is a factor, explain your answer. Okay, so here, what we could do is we could plug in 5. And here, when we plug in 5, like we could just divide this. Yeah, maybe I'll just divide this. So I'll put the 5 on the outside. I'll do synthetic division. And we have 2 is the coefficient of x to the third, minus 4, minus 7, minus 10. And now I bring down the 2. And what we're going to have here, 5 times 2 is 10. This gives me a 6. That gives me a 30. 30 minus 7 is 23. Yikes, that's going to give us 115. Yep, and that's going to give us a remainder of 105. So I could say 2x to the third minus 4x squared minus 7x minus 10. This is our remainder, is equal to 2x squared. So it's like we divided by x minus 5. So let me write that first. It's x minus 5 times, we have 2x to the second plus 6 times x plus 23. Okay. And then what we're going to have here is we're going to have minus 10. So I guess I could just write it outside like this. Yeah, so I'll say minus, I'm sorry, not minus 10, forgive me. Why did I have minus? Oh, that minus 10 was staring at me. The remainder was 105. So plus 105 over the divisor was x minus 5. Okay, so that's like how we interpret this. We have, if we distribute here, like this is what it, like its divisor would be. I'm sorry, this is what the dividend would be, but the remainder is 105. All right, so then this is how we could express it and just say x minus 5 is not a factor. Okay, of 2x to the third minus 4x squared minus 7x minus 10, because it does not divide evenly. Okay, that's one way. Another way of doing this is just plugging in 5. Like you could do 2 times 5 to the third power minus 4 times 5 squared. This might be easier, because if x minus 5 is a factor, means x equals 5 is a root. And that would mean like you set this equal to 0. So minus this, minus 10, and C, is this equal to 0? And when you plug in, you get the remainder 105, and 105 equals 0 is false. So I could just say like, no, when you plug in 5, it's not 0. I say like, therefore, is this a factor? X minus 5 is not a factor. This is probably the easiest way to do it, to be honest, because x equals 5 is not a solution of, and then that polynomial equal to 0. Okay, honestly, what I wrote in blue is like 100, I think 100 times easier. Just plug in 5 and you're like, oh, it's not 0. X minus 5 is not a factor because x equals 5 is not a solution of this equation. All right, that's the easiest. in my opinion. All right, on the axis below, graph one cycle of a cosine function with an amplitude of 3, period pi over 2, and midline at y equals -1, passing through the point 0, 2. Okay, I'm just going to make sure that I draw this nicely. So 0, 2, I mean, I guess I could draw this small. If you want to zoom in a bit, you can. So that's, I guess, entirely up to you. But like, sure, I'll draw it small, like 1, 2, 3. On the y-axis, -1, -2, -3. Now here's this part. They told us that the period is pi over 2. Okay, so pi over 2 is the period. The amplitude is 3. The midline is -1. So the midline is going here. So I would put the dotted, I like to put a dotted line. So this is our midline. Okay, so there's our midline. And now we have the amplitude is 3. So I'll just write that over here. Amplitude is 3. The period is pi over 2. And anything else? Oh yeah, it passes through the point 0, 2. So let me just put that on the curve. So that point has to be there. And it has to be a cosine function. Okay, so cosine, they didn't tell us to write the function, but I think of the cosine graph, it looks like this. All right, and if you're like, wait, how do you know that? You have a calculator. Oops. Forgive me on that. Let me just do this first. So y equals cosine x. Okay. Oh, let me just see. My Regents is tomorrow. Just want to pass. Could you just graph this and see the roots? Yeah. So at Chase, I'm sorry I'm late to the comments. I show it a few ways, but that way, like I said, I think is a lot easier. So I agree with you. Do it that way. I always show students more than one way, just in case some people would rather just do the division. They're like, you know what? I would rather just divide. But yeah, me 100 times, like 100%, I'd rather do it the other way that you just said. So awesome. All right. I love that about the chat. Please, if you have an idea, like share it, make us all better. I really appreciate those kind of comments. So thank you, at Chase. So I appreciate you. Thank you so much. All right. So here, yeah, like if I have to look cosine x, but watch this. If I press graph, like, oh no, it flatlined. It's because I'm back in degrees. You got to make sure when you graph trig functions, you are in radians. Now you see that's what it should look like. All right, so what I was imagining is that's where I'm getting that thought. Now the period is pi over 2. So pi over 2, like let's say a cosine function and a sine function has 4. One of my team teachers like to say it has 4 chunks. So it's like that's the first chunk, the second chunk, the third chunk, and the fourth chunk. Okay, so if I like color code them, it's like this is the first, the second chunk, the third, and the fourth chunk. Okay, and what I think about, and this is also shout out to my team teacher, cosine, you start at the max, then you go to the midline, then you go to the min, then you go back to the midline, and then you go back to the max. Because remember, you want to do one full cycle. So one full cycle means that you should end, you have to end where you started. Okay, and what that means, like where you started, like I would say, like on the y-axis. Okay, so I just think with this, with cosine, it's max, midline, min, midline, max. Okay, so when we do this, now first though, we have to know where the chunks are going. Remember, there's 4 chunks. Pi over 2 is our period. The period is how long it takes to complete one cycle. Okay, so how far we have to go to complete a cycle. So I just want to make sure you get the concept. That's why I'm taking a little longer to explain this. So 1, 2, 3, 4 chunks. Okay, if you want to go out a little more, like you could skip and go 2, 4, 6, 8, and just like you could scale it any way you want. You could say, all right, that's pi over 2. And then more math I do in my head is I say divide it by 4. pi over 2 divided by 4, if you call that 4 over 1, is pi over 2 times a fourth, which is pi over 8. Okay, so that means I'm counting by pi over 8. So more thoughts. I'm going pi over 8, 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8. And 4 pi over 8 is the same thing as pi over 2. 3 pi over 8 would go here. And then 2 pi over 8 is the same thing as pi over 4. And then pi over 8 is here. Okay, but remember what I said before. It's max. Then at this chunk, see pi over 8, I go to the midline. And then at pi over 4, I go to the minimum. Now, one thing, yeah, there's so much to these questions. Sorry about this. The max is equal to whatever the midline is. The midline plus the amplitude. And the minimum is equal to the midline minus the amplitude. Okay, so you see here, our midline is at -1. My amplitude is 3. So if I go up 1, 2, 3, see how that puts me at 2. So 2 is the max. And then minus 3 would be 1, 2, 3. I'm going to go down to, so yeah, just making sure here. Let's see, the amplitude is 3. So if I go minus 1, 2, 3, I have to go down to -4. Okay, so let me just put that in blue. So we're going down to make that neater, -4. All right, so now let's go ahead and do this. So we have max, midline. The min is down here, down, once again, 1, 2, 3. And then I go back to the midline. But you see, I'm going like 1, 2, 3, 4 chunks. And then at pi over 2, I go back to the max. And here is one full cycle. Okay, if I had to write a function for this, well, remember the period is equal to 2 pi over the frequency. So the frequency, I could say, is 2 pi over the period. Just know I could do like this little swap here. So my frequency, I could say, is 2 pi over 2, which is 2 pi times 2 over pi. So if I had to write a function for this, and it's a cosine function, I could say this. Don't do this though, because this will only lose you points. The amplitude is 3. Then I have cosine. My frequency is 4 times x, and my midline is -1. So if I graph this, moment of truth, I have 3 cosine 4x, and then -1. See this? And if I go to my window here, and I go from, on the y-axis, from -4 to 3. Okay, this is how I check my answer. And then I go from 0 to pi over 2. This should give me 1 cycle. And it gives me 1 cycle, okay? Wait a minute. What did I write? -4 to 2. Oh, yeah, because I wrote that extra value here. So if I go -4 to 2, see how it's like, yeah, really squeezing this. So I'm confident in that. All right. So that is 28. All right, let me just move on here, see if the rubric has any, yeah, well, this is only 2 points too, so I probably did a lot of extra, but still, I like to go into detail here. All right, so now question 29. Let me just check the chat, because I'm like probably like, I'm a little bit in the zone right here. Oh, Notability is the best. What's up? And hello, at Tommaso. Nice to see you. How do I multiply polynomials? I think that might come up again. Or at some point earlier, I think I did multiply. XTO, I'm happy to help you with your geometry regions. What did you think of the regions? Let me know. Anyone who took a Regents and is just stopping by to say hi, like, let me know in the chat what you thought. I am, curious what people thought of the regions. All right, so moving on here. A suburban high school has a population of 1,376 students, and They tell us the number of students who participate in sports is 649. In music is 433. If the probability that a student participates in either sports or music is this, so here's the question. What is the probability that a student participates in both sports and music? So for this one, I don't know why, I always think of Venn diagrams here. Because the sports and music, I just that's the overlap. Okay, let me I'll change colors here. That's this. That's what we're looking for. Okay, so if this is sports and this is music, this is sports and music. Sports or music is like any one of these people. Okay, and they're telling us that probability here is 974 over 1376. All right, now let me see. The number of students who participate in sports. So this is the number of sports people. And the number of people who participate in music is here. So I'm going to just add this together. So if we work this out, let's see, 12, carry the 1, 8, 1082 is the number of people who do, I would say, sports, music, but there is overlap here. Sports or music includes all of these. So what we could do here is we could subtract. All right, so if we take this, 1082, and we subtract 974. Just going to borrow 801. That's a gap of 108 students. All right, so they're asking, what is the probability that a student participates in both sports and music? Because if you think about it, the probability that it's sports or music is this plus this plus this. And that's 974. Okay. But what they're telling us is they're telling us the number of people in sports and the number of people of music. So here, when we subtract the two, see the difference between those? That's the overlap between the sets is the 108. And there's 1,376 students. So I'll just say 108 over. I'm going to show you another way of doing this because I think this way, just thinking about it like that logically, can be a little tricky. Oh, I'm so glad. Algebra 1 exam today felt super good. I'm happy that I was able to help you here. I'm just glad to hear that. And we recommend. Oh, wait, I think it's a little bit uncalibrated right now. This stream. I'm sorry. I'm just noticing there's a little bit of a lag, I think, but it's all right. I guess I'm talking and it's going to just put this out there when it does. But I'm glad that the stream was able to help you. Are we able to have 2 calculators? Sure. You could have 2. I can't imagine them making a big deal about that. Yeah, I just hit the reset. Okay. So now the other way of doing this. So option 2. I hope this works. Forgive me if it doesn't. Okay. So option 2. I'm experimenting here. But I've done questions like this before when I was just inspired. I'm going to put an X, a Y, and a Z. So what they're telling us is the number of students who participate in sports is this. So that's X plus Y. See, sports is the people who do just sports, and the people who do sports and music is 649. Okay, the number of students who participate in music is this. So that's Y plus Z is music. So that's why I like the Venn diagram. It makes it very visual. And then they say the probability that a student participates in either sports or music is this. So that tells us that X plus Y plus Z, sports or music, means it could be sports or music, or even it could be even both here. So I'm just going to see what this gives us. I'm very curious. Okay. So now let's see what happens. I'm hoping if I mess this up, then I'm sorry. So let's see. Polynomial simultaneous, number 9. And then go to number 2. And now I have a 3x3 system. Moment of truth. Okay, so I go next. And 1x plus 1y there's no z there, is 649. And then we have 0x plus 1y plus 1z is 433. And we have 1x plus 1y. I'm just curious what this gives, because I didn't prepare the solution this way. I did it a different way. And now I press graph. And y is 108. Okay, so you see here, you could use, I think this way is maybe more easy to understand. So the Venn diagram makes it very visual. Oh, good night to Susanna. Good luck on your test tomorrow. All right. I hope, let me all know tomorrow how you do, like how you feel the test went. I'm curious. You could always send me a comment, or, you know, just enjoy the rest of your day either way. But good luck. All right. So here, once again, x plus y is 649. That's the number of people who do sports. Music is the people who do just music and who do music and sports. And then the probability that a student does either sports or music is 974. That means there's 974 people that do sports or music. So that would be x, y plus z. And then simultaneous solver, y is the probability. Well, y is the number of people who do sports and music. And that's 108. So that's why it's 108 out of the number of kids in the school is this. All right. I like that second way. Oh, yeah. Good luck at Eliana. All right. So this one, think of this vertex form, okay, of a quadratic. So just make it look like this. So here, divide by 12 first. So you see the Directrix, yeah, they give us that, but hang on. If you could already see what the vertex is, then great. But first I'm going to do this. Divide both sides by 12. Wait, what is going on here? So divide by 12. And now I have y plus 3. I'm going to write this as 1/12. X minus 4 squared. And now minus 3. Now, I like to do this the visual way. I can't memorize formulas to save my life. Okay, if you just want to memorize, then memorize away. But I cannot tell you the formula for the focus in Directrix. I know how to derive it, but like it takes forever to derive. So here, the vertex. So the vertex is, let me just write this over more. So vertex is going to be at 4, -3. Okay, so that's the vertex. And this is a positive parabola. It's opening. So 4, -3 means this is the vertex. Okay, and it's going to open like something like this. I don't actually, it doesn't really truly matter like what it looks like. It just that it opens upwards and there's the vertex. And they tell you the Directrix is at the let me use a different color. I'll use pink. The Directrix is at y equals -6. So y equals -6 is down here. The concept of a parabola, okay, so this part's really important, is no matter which point I put on the parabola, okay, is that wherever the focus is, the distance between the focus and a point on the curve, like a point xy, is equal to the distance from here to the Directrix. All right, now I didn't draw this amazing, but that's the concept. The easiest point to target, though, is if you go from the vertex to the Directrix. Okay, once again, that distance has to be the same. So from -3 to 6, if I go straight down, it's 1, 2, 3. Like this, that wasn't a good drawing. Let me try that again. 1, 2, 3. The distance from here to here is 3. So that would be going down 3. So then my focus would be, see how this is the point 4, -3? I have to now go up 3. So if I go up 3, notice I'm at -3. I would go up 3 to 0. I would be here. So there's my focus. Okay, the focus is going to be at 4, 0. So visually is the way. Don't memorize. This is the way. All right, that's question 30. Done. Algebraically prove this. All right, I haven't seen them do polynomial proofs in a while. So here, I would just say, if x is not equal to -2, like we could assume this. You could show left side equals right side or right side equals left side. So I'm going to say x to the third plus 9 over this. You could do division, but there's a cooler way. I made a YouTube short on this. What I think here is like, oh, wow, these are close. These are off by 1. If only I had this, right? If only I had this, then they would just cancel, right? And it would make 1. But how do I make 9? That's 8 plus 1. This is the extra piece. So now this, I'll just show is going over here, is now equal to, I could say x to the third plus 8 over x to the third plus 8 plus, and then that leftover piece, the 1, I could break this up into 2 fractions. Okay, if I needed to combine these, I would just keep the denominators, add, and it would bring me right back. But now, notice what happens. This cancels and makes 1 plus 1 over x to the third plus 8. Okay, so that's how we do that one. So yeah, just algebraically prove. That's the algebra. All right, and we're saying if x is not equal to -2. All right, just know, note, I would write here, x doesn't equal -2 because that would make a 0 denominator. Okay, and then we would have something undefined. So I might just casually sprinkle that in. All right. A house purchased 5 years ago for 100,000 was just sold for this. Assuming exponential growth, approximate the annual growth rate to the nearest percent. All right, annual growth rate, I'm thinking of this formula again. And it's growth, so it's 1 plus r. So a house purchased 5 years ago, the principal value is 100,000. And the amount that it is today, or whenever it was, after it was bought. The restriction, the restriction is unnecessary at Nathaniel Silver. So I would say, like, don't write too much extra, but if it gives you peace of mind to say one extra thing, it's like, don't say too much extra because you could say one thing that's silly and then you lose. All right, but yeah, you're most likely fine there. All right, so 135,000 is the amount, equals, the principal is 100,000. Making sure I'm writing enough, times 1 plus r. And the house was purchased 5 years ago, so t equals 5. Okay, so just divide both sides by 100,000. I'll make that look nicer. So we get here. And now see you later to those. And dividing this by 100 makes it 1.35 equals 1 plus r to the 5th. And now we're solving for r. So we're going to take the 5th root of both sides. That's going to get rid of that power 5. And I'm going to have 1 plus r equals, and now calculator, unless you have a computer brain. Thank you for the help. Oh, just Trippin, I'm happy to help you. I appreciate the comment, or you writing in the chat. I have to once again thank everybody. I know this is day 3 of me live streaming in a row. Day 4, actually, I did 2 nights for geometry. So I'm definitely like feeling the burn a bit, but I'm going to finish this because, I want to do a service. I initially honestly was not going to do Algebra 2 because it's not a popular Regents, but like one subscriber asked me to do it. And I'm like, you know what? I don't care that this is not the biggest Regents because Algebra 1 is like massive compared to Algebra 2 in January. I'm doing this like I mean it, like I'm happy to help you all. it means a lot to me. Like when I teach at my high school, I have like, let's say around 100 students. And, you know, don't get me wrong, I care about all my students a lot. But knowing that like I'm able to help, you know, like 284 people watch this, that's like basically like close to triple the number of students I have in school, you know. So I like that I know that I'm helping people across not just the city, but all of New York State, or some people out of New York State are just watching. So thank you for being a part of this and helping this channel grow. You know, I really do like value this community, and it's called like not like just when you're older, but it's called like filling up your, like you feel like you're getting fulfillment in life, and knowing that I'm like able to talk with all of you and connect and, you know, teach you some math, and you're all trying to better yourselves. Like I do appreciate it like more than, you know, you may realize. So thank you, you know, and I really do mean it. I'm glad like we could all be doing this right now. All right. There's not a lot of people, I guess, who would want to stay up late like doing math, but you know, like if I was like a future employer, like people like you would be hired, you know, like that you're willing to put in this type of work to get after it. Okay. Oh, so fifth root. My bad. I'm talking as I'm saying it. So math number 5 allows you to make a custom root, like the fifth root, and then 1.35. Okay. And then notice I'm going to have to like subtract 1 in a moment. So I'm going to just do that now, like minus 1. All right. That brings me here. So this is this. The fifth root, I'm just going to write. The fifth root is equal to 1.0, and they said to round to the nearest percent. So you know what, like I guess I'll write a few spaces now, like 1.0618, and then that 5 I'll round to a 6. Okay, so like minus 1 point, all these trailing zeros. So r equals this. However, if we look, they said to write it as a percent. So when you want to go from, so here's some middle school math, from decimal to percent, you go times 100. Okay, so this r equals this times 100. Okay, and it's a percent. Now if I move this 1, 2, they said to the nearest percent, this is just going to work out to, see, like 6.18 blah 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 percent, but 6% because there's a 1, so we round down, so 6%. Okay, that's us rounded. Cool. All right, 33. Part 3. Here we go. Solve the system algebraically. All right. So here we go. Someone said multiplying polynomials. And that's what we're going to do at some point. So the key is you take the linear one and you plug it into this complicated one. Okay, so this is like a circle and a line intersecting. And I just imagine like, I'm imagining like a circle. You know, so here's like, this is not it, but I mean, I guess 1, 2, 3, and then 1, 2. So there's the center. The center is technically like not on the circle. But the radius would be 4. So it would go like, I don't know, like not like amazingly drawn to scale. But I'm just imagining like, I don't know, something like this. And then that's the line x plus y equals 5. I'm just dividing everything by 2. So that would be like, I don't know. I'm imagining like, yeah, this line. So I'm imagining like, all right, 2 solutions for sure. So it helps, like they said algebraically, but use your imagination so you know like what answer is reasonable. So here, I'm going to take that equation. So this one, and I'm going to divide everything by 2. So I'm going to divide left side by 2. So this gives us x plus y equals 5, which then this gives us y equals 5 minus x. So now this, I'm going to plug in here. Okay, so I'm going to have x minus 3 squared plus, instead of y, I'm replacing y with 5 minus x plus 2. I have to just write squared is equal to 16. And now this is the same thing as x minus 3 squared plus like terms 5 plus 2 is 7. 7 minus x squared equals 16. And now we've got x minus 3 times x minus 3 plus 7 minus x times 7 minus x. And we have to expand this. Please don't say x squared plus 9. All right, that's the most common mistake, like in math. Don't just do first thing squared plus second thing squared. We're going to do x times x. So x squared minus 3x minus another 3x plus 9. And now this one, 7 times 7 is 49. We got minus 7x. I don't know what's going on here. So minus 7x, and then we distribute minus x. We get another minus 7x. And then we get plus x squared. Because a minus times a minus is, going to go plus. Okay, now we combine like terms. So let's say we got x squared and x squared makes 2x squared. We've got minus 3x minus 3x minus 7x minus 7x. So that, I'm doing minus 3 is minus 6. Minus 14, that's minus 20. Oh, absolutely. This is going to post on the stream. So if you want to go to sleep and then watch this tomorrow, by all means. All right, I'm just finishing it tonight because I have work tomorrow. Like I'm a teacher, so I have to go in the morning. So this is it for filming. So 2x squared. So good. If that's the case, good night and good luck tomorrow at Overcooked. I hope the test goes well for you. All right, so best wishes tomorrow. All right, and now here we have 9 plus 49 is 58 equals 16. And now just go minus 16. Okay, and minus 16. I hope I didn't say something crazy here. If I did, I got to go find my mistake. 2x squared minus 20x. And then that's plus 42. And now you can just factor out a 2. Oh, it worked. Okay, cool. All right, I'm going to shrink this because we are going to need that space. So let's take all this, group it, and shrink that down. Okay, so this now factors to x minus 7 times x minus 3. I'm getting these factors from the idea what two numbers have a sum of negative 10 and a product of positive 21. So it's those. Don't say 2 equals 0. That's just silly. This will give you x equals 7 as a root, and x minus 3, that factor gives you x equals 3. If you stop here, sad day. All right, you have to plug in to find the corresponding y value. I would plug into the easy one. Okay, so I would plug into this. So let's go ahead and do that. When x equals 7, see, we would have 2 times 7 plus 2y equals 10. 2 times 7 is 14, so I'll just write minus 14. And these cancel because 14 minus 14 is 0. And then 2y is equal to negative 4. So y equals negative 2. All right, so when x equals 7, y is equal to negative 2. So 7, negative 2 is one of our solutions. Okay, we have 2 solutions, but this is one. And now the next solution, I'll just box off here. We're going to plug in x equals 3. And we're going to have 2 times 3. Remember, I'm plugging into the easy one, not the crazy one. 2 times 3 plus 2y equals 10. 2 times 3 is 6, so subtract 6, and 6 minus 6 cancels. Then you have 2y equals 4. So this gives you y equals 2. So our second answer, when x equals 3, y is equal to 2. So this here, like these are the solutions. All right. Whew, that one's a lot. All right, we're getting there. 34, 5, 6, 7. All right, the rest aren't like terrible. Oh, so geometric series, go to the back of the test. In the back of the test, they have formulas. So let me see here. Take a picture. So you go to the reference page, and they said geometric series here. So I'll just show you. So like you go to the reference page. Sorry, this might not be the highest quality screenshot. And at some point, we have to write a geometric series formula S sub n. So the geometric series formula is here. All right, so I'll just borrow that. I'm going to say S sub n equals a1 minus a1 r to the n over 1 minus r. Okay, r can't be 1. All right, but it's not going to be here. So that's on the reference page. I will move this out of the way now because we will need the space. So now Alexa earns $33,000 in her first year of teaching. Oof. All right, yeah, so they're talking about the profession. This Regents is old. Teachers make way more than that now. Right, but yeah, at one point they used to make $33,000 in their first year and earns a 4% increase in each successive year. So they really like this formula, the 1 plus r to the t concept. Okay, because 4% is the same thing as 0.04. So that would be, now here's the challenge here. I'm going to erase this because r could be misleading. R in this context though, a 4% increase is, to find a 4% increase, just, I'll say multiply by 1 plus this. So multiply by that. So in this question here, r is 1.04. Okay, so that's her percent increase in salary each year. Write a geometric series formula S sub n for Alexa's total earning for n years. See, this is probably not the name to use anymore because everyone's echo dot is going to go off. Sorry if anyone's name is Alexa here. But I think that name like trended out in word problems like for that reason. So yeah, I'm sorry to anyone named Alexa. Like, it's a nice name, don't get me wrong. I'm just saying this is before Amazon took over the world. All right, so minus r and then to the n power over 1 minus 1.04. You could leave it like this. You don't have to simplify all this. Okay, we could leave it like this. So write a formula for Alexa's earnings over n years. And here's the formula. And now use this formula to find Alexa's total earnings for her first 15 years of teaching to the nearest cent. So this is when n is equal to 15. So we just plug in S sub 15 is equal to 33,000 minus 33,000 times 1.04 to the n power. See, n is equal to 15. And we divide by 1 minus 1.04. For this, here's a calculator trick I would really recommend you use. Is alpha y equals enter. Okay, and you have 33,000 minus 33,000 times the rate is 1.04. That's the 4% increase to the 15th power. And then you go to the denominator, 1 minus 1.04. And it gives you this. Okay, now just so you could like make sense of it, a common mistake here is people are going to leave out that 1. You know, like they're going to do this. They're going to say like 0.04 and 0.04. Like they're just going to, do 4%. But watch what happens. Does this make sense? Alexa works. So this is like, if you know my other videos and my style, I talk about the bear trap. Does this make sense that in 15 years, okay, so 15 years goes by and Alexa earns $34,375. She earns Like if her first year salary is 33,000 and it doesn't change, she would earn like 66,000 in 2 years. That is way too low. So hopefully, like you see that your alarm bells should go off. You should say, wait a minute, like something's not right here. Okay, and you should go back and fix it. So that one here is the true answer. S sub 15 equals to the nearest cent, that's 2 places, so just 39, we're going to stop, is 660, 778.39. So her earnings, I'll just write over here. You want to write it in money form. And 39 cents. There it is. All right. So that's 34 conquered. 35, oof, simulation. This is 2 simulations in one test. So here though, you see, it's like, once again, 2 confidence intervals. So I'll get rid of this craziness here. So students attending the prom were randomly selected to participate in a survey about music choice. 60% responded that a DJ. So 60% say a DJ would be preferred over a band. And members of the prom committee thought that the vote would be 50% for DJ and 50% for the band. So we want to see, like, is 60% like unreasonable? So they run a simulation 200 times, each of sample size 55, based on the premise that 60% of students would prefer a DJ. And the approximate normal simulation results are shown. Use the results to determine a plausible interval containing the middle. All right, so middle 95% is the mean plus or minus 2 standard deviations. Okay, round all values to the nearest hundredth. So this is like mindless. Okay, like, whoops, wrong button here. Let me just fix this. All right. So honestly, this, like, once again, I'm just doing the mean, 0.602 plus 2 times the standard deviation is 0.066. And then I go up to it. I press enter. And I'm going to change that to minus. Okay. And here we are. All right. So we have this. And the middle 95% is 0.47 to the nearest hundredth. This one is just going to be 73. Okay, if we don't round, that is a very annoying way to lose a point. Okay, so now we have to use this to analyze. So they tell us, let me fix this. Members of the prom committee are concerned that the vote of all students attending the prom may produce a 50-50 split. Explain what statistical evidence supports this concern. So members of the prom committee are concerned that the vote may produce. I thought, let's see, thought that the vote would have. Oh, so there's the concern. All right, so why does the statistical evidence support the concern? Well, 50%. If you look at it, it was, let's see, what is the simulation showing us? What percent prefer a DJ? So you see, like, a 50-50 split here. So I'll just say this, a 50. I got to fix this. Yeah, this is driving me a little crazy. All right, so 50-50 split corresponds so this is called survey proportion, corresponds to a survey proportion of 0.50. And notice 0.50 is in the middle 95%. It's between here. And I'll say, and 0.50 is between 0.47 and 0.73. So here I would say next that since 0.50 falls in the middle 95% interval, a 50-50 split is not unusual, or would not be unusual. Okay, that's very possible that it could happen. Okay, so that would get you the credit here. All right, we made it past the simulation. Let me check the chat, see how everybody's doing. All right, let's just see. So yes, this will be posted. So moving on. So which function shown below has a greater average rate of change on the interval -2, 4? So for this, all I'm thinking about is this formula, f of b minus f of a over b minus a. All right, and what we have, we want to know which function has the greater average rate of change from -2 to 4. So I would find the average rate of change of f of x on -2, 4. Is f of 4 minus f of -2 over this. So now I just go to the table here. See, the function value at 4 is 80 minus the function value at -2 is this. Divided by 4 minus -2 is 6. So that's all calculator work. All right, so let me just go ahead and do that. So let me just see. So I have this, and I'm just going to do 80 minus 1.25. Press enter and divide by 6. 13.125. All right, now next, oh, you could use that one. So at not Darian, yeah, you could use the slope formula, 100%. I'm going to show you a little trick here, though, for g of x. Let's say I write that in the function, like I write the function here, 4x to the third minus 5x squared plus 3. And now I go here, alpha y equals enter. A nice little trick, you could press alpha trace y1. And I'm doing the function at 4. So I put parentheses 4 and I close it. Minus, and remember, g of x I saved in y1. If you don't have that shortcut, you have an older calculator, you press vars, go to the right, function y1. And I'm doing the function at -2. And now I divide by 4 minus -2. I'll pretend that I don't know that's 6. And then I get 38. Okay, so the average rate of change of, wait a minute, did I write something crazy? Let me just double check. So g of, okay, I'm going to double check though. I want to make sure I don't put anything crazy out there. So let me just see here. This is question 36. Yeah, 38. Okay, just making sure. So that works out to 38. So back on the main screen, I'll just borrow this. Okay, or what you could do is you could go to the table and just look up like -2 and 4. So second window, put it back to auto, And I'll say I'm counting by ones in the table. I'm starting at 0 and counting by ones. And from -2 to 4, you see I could just like grab these values here. And this is also okay. All right, so if we did 179 plus 49 and divide by 6, see like these values here. So I got this and I got this. All right, if I plug those in, I'm going to still get the same thing. But that's just a nice little calculator shortcut. Okay, so the average rate of change of g of x on -2, 4 is, and I'll just say here like what I found, like g of 4 minus g of -2 over 4 minus -2 is 38. All right, let me just... All right, is this. So now you just have to justify which function has the greater rate of change, g of x. All right, so just make your decision. Like g of x has the greater average rate of change on -2, 4. All right, that's it. That's all we got to do. All right. Oh, Anthony, I'm glad. Thank you for the comment. I'm happy to help. I appreciate your comment. And once again, to everybody here, thank you and good luck tomorrow. I really hope you all do well. And we have made it to the last question. All right. Is this one a little bit annoying to graph? I think it is. Okay. So here we go. This one, 6-pointer, drugs break down in the human body at different rates and therefore must be prescribed by doctors carefully to prevent complications such as overdosing. The breakdown of a drug is represented by this n of t function here. Okay, so that's our function. N of t is the amount left in the body. So this is where it gets important. Amount left, N naught is the initial dose, R is the decay rate, T is the time in hours. Patient A is A of t. They're given 800 milligrams of a drug with a decay rate of this. And patient B is starting off with this much, and their decay rate is here. And the first thing we have to do is write a function for A of t and B of t to represent the breakdown of the respective drug given to each patient. So A of t, I'll write in green. So A of t is N naught, that's the initial amount, is 800. And then it's e to the negative r, and r for this person is 0.347. And it's a function of t, so notice here that there's a t here that I have to sprinkle in. And now pink will be B of t. So B of t is equal to 400 e to the power negative r. Okay, here like this. All right, so there it is. And from here, what I'm going to do is I just have to graph each function. So this is where the calculator is going to come in. And really what we have to do is find an appropriate scale. Now this is starting at 800. So I know I'm going to have to go up really high here. All right, this is going to have to go way up. So I'll type these both in. So 800. And we're going 800e to the power negative 0.347. And I tack this on. And then I have 400 e to the negative 0.231 times x. And now, if I go to the table, see how like, I don't know, these values here are going to be like pretty significant values. So I'll just borrow these. Okay, these are the values that I want to use. Graph each function. So this one here is A of t. and this one is B of t. So if I had to come up with a scale, I think it's best to count by 50s. So I'd have 100, 150, 200, 300, 400, 500, okay, then 6, 7, then 8. All right, if you want to go a little bit above, you can, 900. And now here in this direction, I could just go 1, 2, 3, 4, and then 6. I just don't want it to be too cluttered. All right, here like this. That's probably our best bet. So now I'll color code this to 0, 800 is the first point. At 1, we're going to like 565. So that's like somewhere here. It doesn't have to be exact, but I write these values next to it. At 2, we're at 400. We're a little bit under. All right, but like I said, the table is what makes this like as accurate as possible. 3, we're at 280. All right, so 280-ish would be around here. And then 4 brings us to 200. And then after this one, I might just skip over to 6. Like, you don't have to do every single point. All right, you could just get a bunch of these. And like 10 brings me down to like 25. So I'm like here. All right, like around 25. So then now I just connect this. And it's easier to do this on paper than like on a computer. So I got this, this. All right, it looks something like that. Okay, and I'll just put an arrow at the end here just to say it's like decreasing. And now in pink, I'm going to do this one. So 400 and then maybe 250 at 2 is like around here. And then it looks like another good one would be at 6, brings me to 100, which is like a little bit above this one. And then at around 9, I go to 50. And it's a little over 50. Let me, make that neater. So 1, 2. All right, so something like this. It doesn't have to be perfect, but yeah, that's the idea. If you want to label these, that's probably a good idea. Call this A of t and write B of t next to the pink one. Okay, so now they're labeled. And from here to the nearest hour t, when does the amount of drug remaining in the patient B begin to exceed the amount of given drug in patient A? So you could see like around here is where they overlap. Like that's the intersection point. So that would look like it. All right, if I wanted to be precise, so zoom 6 doesn't help us. Remember, this is going up to like 900. So if I go up to 900, now I'll see what's going on. And if I want, I'll start at 0. So we get a better picture. Press second trace number 5 for the intersection. And I just press enter 3 times. And you see it's at 5.97-ish, 5.9754. So that's really close to 6, to the nearest hour. So the nearest hour t, just say t equals 6 hours. Okay? And you would say like that's like close to where the graphs, close to where A of, like I'll say, yeah, the graphs of A of t and B of t intersect. All right, you don't have to mention this because they just said to the nearest hour. They're just basically saying determine. But I'm just like kind of explaining the reasoning here. Okay, that's the closest integer value. So t equals 6 hours. And now we have the doctor will allow patient A to take another 800 milligram dose of the drug once only 15% of the original dose is left in the body. Determine to the nearest tenth of an hour how long patient A will have to wait. So this, you know what? I want to say here we could use the calculator. They didn't say do this algebraically, but the 800 milligram dose, 15% of that, I just multiply by this. And I'll just say, like, let the calculator do its magic, is going to give us 120. And now if we remember, patient A was A of t, was this function, 800e to that power. Okay, so just remember A of t. So I have it written down. A of t, yeah, this is really like frustrating. Okay, A of t equals 800e to the power negative 0.347. Okay, times t. So that's our function A of t. And if we want to know, determine to the nearest tenth of an hour how long patient A will have to wait to take another 800 milligram dose, we're going to set 120 equal to 800e to this power. All right, and I'll show the algebra because on some regions they'll say do the algebra, use logs. So I divide both sides by 800. Okay, and 120 over 800. Well, this cancels out, and if you divide the top and bottom by 4, that's 3 over 20. Okay, or just do math, enter, enter, equals e to this power. And, oh, we have 3 minutes before the 3 hours, so I want to try to keep this in 3 hours. Even though I did have to stop, like I did talk to a lot of people. But now, to get rid of e, I natural log both sides. Natural log and e are opposites, so they just cancel out like this. Okay, now I have natural log of 3 over 20 equals, the exponent is all that's left. And now to solve for t, just divide. And we're going to round to the nearest tenth in a moment. So t equals, and with 2 minutes to spare. Okay, so we have natural log of 3 divided by 20. And now we're dividing by negative 0.347. Okay, and we get this. To the nearest tenth, that is going to be 5.5. Okay, and hours. So 5.5 hours, 5.5 hours is the time. Now, let's say, okay, because we still have a smidge time left here. All right, oh, I don't know if the time, like, it's kind of freezing up a bit. But if I want to, I could graph like 120. I could say, when does this hit 120? And I'll do that in pink. And when does it hit the first graph, A of t? So maybe I'll turn the second graph off. I just press enter on the equal sign and it turns that graph off. And I could just do second trace number 5. And if you don't feel like doing the algebra, if they don't tell you to do the algebra, just say, I did second trace 5. Okay, like you could tell that, you could communicate that to them. Just say, hey, I did second trace 5. Like when you get here, you're like 120 equals 800 e to this. Just say like second trace 5. And then say like t equals 5.5. Okay, like you just, if you even want to just draw like a sketch even, that's fine too. All right, so that is, yeah, that's that. That is the Regents. We finished. Whew. All right, that was, yeah, very tiring. But I'm glad we got through this together. All right, it is 11:04. Yeah, that is basically all I've got. So before I check out, I just want to say thank you to everybody who stopped by and had something, to say, something nice, encouraging each other. If you're nervous, just show up tomorrow and do your best. You try to convert that nervous energy into test energy and really try to get after it. But once again, I really do thank you all for swinging by and supporting. And if you watch my other Regents videos, like, thank you. I really do appreciate it, and good luck tomorrow. So I'll say goodnight and take care.